to listen to a webinar about play in early years science education. We had some little technical problems, but we are now over of those. So let's start. Thank you very much for joining us today. And today we will discuss about why we should teach through play rather than direct instruction. I will also describe you a playful inquiry model, a concrete pedagogical model that is proved through academic research as very effective way to approach early years science education. And we can also test by ourselves a little experiment that will draw you a picture of how this playful inquiry model really works. So I really hope that you enjoy the webinar. And something about me. My name is Dr. PhD Jenni Vartiainen. I work as a researcher and a university lecturer at University of Helsinki. I'm founder of Kide Science. Kide Science aims to bring play-based, story-based inquiry learning for children all over the world by helping teachers to do play-based learning. I'm expert especially in early STEAM education, early science education, and playful learning in general. I have written science books for children and also guides for teachers how to do play-based science education with children. And I'm also I have also acted in a children's science TV show in Finland that basically all Finnish children have been watching at their homes. So I'm very interested in popularizing my research in many different ways. But now, let's go to the topic of our webinar today. So how we can engage young children in learning science. Probably all you have been with children in your work, or you have been with your own children or some of your friends or relatives' children. And you know that children are the masters of wondering. They constantly ask different kind of questions. And if we look at research, a kindergarten child might ask even 107 questions on the average during one single day. So that's a huge amount of questions. For example, what animal eats the most? Are crocodiles happy when they have babies? Or what if we could walk on the clouds? And these what if questions are such questions that young children are especially good at. And what is the power in what if questions is that what if questions are basically those questions that make the world change. For example, someone has asked at one point that what if the earth isn't flat at all? Or what if man could fly? So we really want children to keep on asking these what if questions, especially during these times when we are living in the middle of eco-catastrophe and we really need new innovative ideas of how to solve, for example, problem of too much plastic in the oceans or too much carbon dioxide in the air. So we need those future citizens and future scientists who are able to ask what if questions and use their imagination, also in the context of science and STEM. And in Kide Science, we want to emphasize the A in STEAM. And the A part is basically all about the imagination. How we help children to maintain their natural curiosity and their natural ability to use their imagination. But something that we still are not very clear of is how we should approach STEAM education with young children. This is something that also in the research we are still trying to find out. And the problem is that usually we use strategies to approach science with young children that we take from schools and the strategies that we usually use with school-aged children. And why it is not working is that young children should have a possibility to learn by playing. And often if we talk about school-aged children, older children, they probably don't have that strong emphasis on play practices. So we really need to figure out how we can use imagination and play in young children's science or STEAM education. Many researchers have agreed that the only appropriate way to introduce science for young children is through play. And why play is so powerful? First viewpoint is that when we approach earlier STEAM education through play, is that children have a high level of agency and they have possibilities to make decisions. So when we invite children in play environments, we give children possibilities, for example, to decide where they want their inquiry practices to go and what kind of questions they feel important to learn more about. And for example, Vygotsky has shown that when children learn by playing, they are in fact able to exceed their actual level of performance. So in play, children are a head taller. And that comes from the idea that play creates a zone of proximal development for children. So this play practice and interaction within the play is such that it scaffolds children to do better than what they do without the play setting. And play makes learning child-centric. And that is something that we really struggle nowadays. If we look at research that has scrutinized what happens in a kindergarten during a one single day, and that study was conducted in Sweden, in Portugal, and in US. And the results from the US revealed that teacher talks 58% of the time during one day in kindergarten. So over a half of the whole kindergarten day is about teacher talking. 1/3 of the days went in different kind of transition situations. So children were going outside, they were putting their clothes on, or just going from different rooms to other rooms. And that didn't even include, for example, lunch or meal times or sleeping times. So it's a huge amount of time that children have to spend in transitions. Children had about 14% of the time to use for play. And when the researchers paid attention to how much time children can use in interacting with other children in the learning situation, it was only 1% of the time. And you have to remember that these are averages, so there are kindergartens that do very well in child centricity and where children have possibilities to interact with each other. But on the other hand, there are kindergartens that do even worse. So we really need to pay attention to how we make learning child-centric and make it feel meaningful from the viewpoint of a young child. Play allows children to have a high level of engagement. So play is always a voluntarily activity. So you can't be forced to participate in a play situation. And when children have chosen to participate in a play, also their engagement is very high. And if we build our learning around the play situation, then we can have the situation when children's engagement for play and learning through play is very high. Play also supports children's identity as capable learners. It's very important that children feel that I'm good and I'm capable and I'm able to learn different kind of things. And in play setting, there is not such a situation that children fail, but play allows children to take different viewpoints. They can try out, they can test, and they can take different roles and just learn how it feels like to be in different roles or try different kind of things. So it also supports their idea of themselves, of capable learners and capable persons. And before we go to see in more details what kind of pedagogical approach is such that can help children to learn science through play, we should remind ourselves what are the main aims for early years science education. So the first aim, according to almost every curriculum all over the world, is to support young children's idea of themselves, of good learners. So support children's identity as a competent learner. And the second main aim is that children learn so-called science process skills. And by science process skills, I mean the set of very basic skills that can be applied to different fields of sciences. So it's not only about natural sciences or physical sciences, but this kind of physical sciences are excellent possibilities to practice science process skills because their nature is such that you have there usually some kind of experimental situation where you do things hands-on and you use your senses to collect the data. Shortly, what science process skills are. The most important science process skill that all other skills are based on is skill of making observations. So basically it's about using your senses to describe what you, for example, see, what you can hear, what you smell, what you feel. And always the observation requires, of course, possibility to somehow describe your observations to other persons. By measuring, you can make your observations more accurate. And with young children, measuring starts from using, for example, Lego blocks or maybe the length of your finger as a unit to do measurements. And a bit later you can move towards standardized units. But first, it stems from children's own body or the objects that are very familiar for them. Then we have classification. So the idea to classify objects or things according to observations you have been doing. And this starts from very simple observation that you, for example, put things in two different classes. And when children's classification skills proceed, then you can start doing a bit more complex classifications. But it's important that children can also decide what are the rules for doing classifications. So then the idea of what really classifying means unfolds better for them. Interpretation is a skill that is very tightly connected to observations. And in everyday life, you really can't distinguish these two from each other. When we make an observation, we usually directly do interpretation. What does this mean? Why this kind of observation happened? But when we talk about science, it's important that teacher can distinguish these two skills from each other, because observations should always be such that every single observer can do exactly the same observation. But interpretation is always dependent on the person who does that interpretation, because it's connected to your earlier knowledge or your earlier experiences or what kind of attitudes you have. So in interpretation, we basically explain our observations. Prediction is pretty similar to interpretation, but in interpretation, we kind of look to the past. Why this happened? How do I explain it? And in prediction, we look to the future. What do I predict that might happen in a future according to my previous observations and interpretations? So basically, ability to do predictions is a sign for us that learning has happened. And the final science process skills is conclusion. So ability to draw together different kind of observations, measurements. You have been doing classifications, interpretations, predictions, and then you can form a conclusion that is an answer to your original question. There in the middle of all science process skills is communication. It's very important also in the context of science to be able to communicate what you think, what you are doing, what you want to do. And with young children, we have to pay careful attention to that we allow young children to use different kind of communicational tools. Children's verbal expressions are still developing. So utilizing, for example, videos or recordings or photos is very important in young children's learning. Stories and narrative thinking is very important also in the context of science. We sometimes think that science is such an area that we only need logical mathematical thinking, and that is the only goal that we should develop. But many researchers and theories indicate that in fact, if we use this kind of narrative approach to science, it's complementary to logical mathematical thinking. And because narrative way of thinking is inherent for human being and also for children, that is very effective way to start introducing science by using narratives and stories to children. It also helps children to relate themselves to STEAM concepts, because often STEAM concepts are quite abstract, and for young children they might feel very distant. So then we can build more meaningfulness in learning. And next, I will show you a video of an example where we use a narrative approach to one science experiment that you can do with young children. And I really would like you now to pay attention to how the narrative supports children's learning, in a sense that what kind of motivation it builds for children to do the experiment. And on the other hand, I would like you to pay attention to how children are encouraged to use science process skills in this example.
Hosuli the robot is feeling weak. He has a terrible thirst, but he absolutely cannot remember the only liquid that can satisfy it. The problem is, robots only drink every 42 years. When Hosuli tries really hard to remember some information about the liquid, he only remembers this. The liquid doesn't easily mix with the other liquids in his workshop. Will you help Hosuli to find his drink? Okay, we need some help here. Is anybody there? Cuckoo. Amelia. Amelia? Hey. Is everything okay? Amelia? Did you drink the soda? Okay. Okay, stop. Everything is fine, Amelia, that happens. You must have been really thirsty, just like Hosuli. It's good you found something that quenched your thirst. But remember, while doing research, you should never taste anything without permission. Now we must help Hosuli the robot find his drink. First, make observations of the liquids. What colors do you see? What do you smell? Oh, be careful. And you people at home, put all of the liquids in see-through glasses. Carefully observe all the liquids. What colors do you see? What do you smell? Then make an interpretation. What is this liquid? How did you get to that conclusion? When you have done your observations, you can continue to the next phase of this experiment. Now you need an ice cube tray and a spoon. Choose one of the liquids. Measure 1 spoonful of the liquid and pour it into a slot in the ice cube tray. Now pick another liquid. Measure 1 spoonful of the liquid and pour it into the same slot you put the first one. Observe. What did you see? What about the other liquids? You should continue on with the other liquids until you find the one that doesn't mix with any of the other ones in Hosuli's cabinets. And scientists at home, don't let the adults do the job for you. You are the lead scientist in helping Hosuli find his drink. Bye!
So that was an example when we brought in a story to motivate children to do this kind of very traditional experiment where we study solubility. And maybe you noticed that all the time the narrator encouraged children to engage in learning science process skills, make observations, make interpretations, measure. So the point wasn't to teach about solubility or anything around these concepts, but the point was that children can engage in an inquiry task and they are able to practice science process skills. And the story, there we had a reason for children to do the activity. Without the story, the activity itself might be fun activity for children, but still there is no motivation why we are doing it. What is the reason behind it? So by utilizing story, we can strongly motivate children on why we are doing some kind of activities. And the story also gives children words, how they can describe their observations and what kind of interpretations or predictions they can make.
Hosali the robot is feeling weak. He has a terrible thirst, but he absolutely cannot remember the only liquid that can satisfy it.
Okay, so after that one example, now we can go and see what does playful inquiry model look like. So the first example was about utilizing stories in children's experiments and inquiries. But now we take one step further, the idea of how children can engage in a play while they are doing inquiries. And this model is produced through an academic research that I have conducted with my colleagues at the University of Helsinki. The playful inquiry consists of 3 phases. The first phase is that we trigger the playful situation. The second phase is about doing experiments and doing explorations within the play situation. So basically there we practice science process skills, we practice problem solving skills, social skills. And the last phase in playful inquiry is about drawing conclusions, so that we learn to communicate about what we have noticed, what kind of solutions we have created, and then share the results with others. And usually, when playful inquiry is going on, new questions and ideas always emerge. So that can be a trigger for a new set of playful inquiry. But let's have a bit closer look what these different phases really mean. So when we trigger the playful inquiry, the point is to invite children to take playful roles. So children can decide what kind of role they want to play in the situation. They can be, for example, little scientists or little investigators, or they can be even dinosaurs if they feel that this is the character I want to play in this particular play situation. The role of teacher is more to orchestrate the play by using the play plot. So the story helps children to move forward in inquiry, and teacher is the one who orchestrates the story. And stories and poems, they have also other purposes. So stories and poems, they trigger children's curiosity and they set the aim for the inquiry. so the meaningfulness is strengthened. The experimenting phase. It's important that we use open-ended problems. So that allows children to take high level of agency. It allows children to test their own ideas and even start their own mini experiments within the larger playful inquiry. Open-ended problems also makes it possible that we consider each child as an individual, and then they can do the experimenting or problem solving at the level they naturally are at the moment. So when we have group of 5 years old children, it's for sure that every children have their own individual developmental level, and we should take that into consideration. We have also heard a feedback from the teachers that the open-ended problems that we use in our playful inquiry lessons is such that, for example, children with ADHD, they are able to engage learning situations because they can participate in a ways that is natural and feels good for them. And as we agreed earlier, the main aim for early science education is to practice science process skills and put heavy emphasis on positive experiences. So the experimenting phase should concentrate on giving children various possibilities to practice science process skills, and always we find those moments when we can praise children and show them how well they are doing and how they have succeeded. In conclusions and communication phase, it's important that we somehow collect our observations. We have documented those, maybe drawing, maybe taking pictures, maybe using recording devices, but we collect those and bring those together. And in stories, we always invite children to send their reports back to the story characters. If the character is in trouble, children then give advice how they get out of that situation. And that helps children to embed their new learned aspects to their future experiences. So then we can root the learning in the wider contexts, and it's easier for children to memorize those moments later. And of course, we learn about rich and versatile modes of communication. It's important nowadays that we learn to use different kind of tools for our communication, and how we, for example, use critical thinking skills when we are thinking about what we have done and what kind of solutions we have, for example, created. But this might feel now a bit confusing, so let's see a concrete example how this kind of playful inquiry task might proceed. And at first I will show you a video of a very traditional baking soda and vinegar experiment. So let's see first how quite often this kind of activity is done with children. Okay, there was great amount of joy and happiness when this or child recognized that the balloons really inflate. But if we now critically think, what did child learn in this situation? And I claim that child learned absolutely nothing. The point was that an adult did basically everything. Adult measured the vinegar in the bottle. Adult measured baking soda inside the balloon. Adult attached the balloons, and everything the child was allowed to do was just lifting up the balloon so that the baking soda dropped down and reacted with a vinegar. So how we could translate this activity into a playful inquiry? So first, I would like to invite you to enter the Supraland with me. Here's the picture of Supraland. And Supraland is a beautiful place in different universe. And you can enter the Supraland by utilizing your imagination. So let's use our imagination and travel to Supraland. In Supraland, we have many friends. In Supraland, there lives Mrs. Noblegas. There at the left side of the picture. There is Kelvin. There is little robot the Hoseli. There is Esther, and there is Pi. And now we have received a letter from Hoseli the robot. Let's see Hoseli's letter. So Hoseli writes to us, "Hello scientist friends, I need your help. I'm supposed to be arranging a balloon party for my friends in Supraland. There is just one teeny tiny problem. I cannot blow into the balloons since robots don't have any lungs. How else could I fill them up? I've sent you some supplies from my workshop. Regards, Hoseli." So now we have invited children to step into Supraland with us. We have let children to choose what kind of role they want to play, what kind of little investigators they are today. And we have read a story for them, and we have created a motivation to help poor little Hoseli the robot and help to inflate balloons. Then we introduce the supplies for children that Hoseli has sent us. Hoseli has sent us white powder. We can first practice doing observations with white powder so we can smell it. It doesn't smell anything. We can try it. It's very nice and soft. And we can name it to children that it's baking soda. Then we have transparent liquid. Quite often when children see transparent liquid, they right away make an interpretation that it's vinegar. But we can do observations and smell it. It really doesn't smell like water. And we can name it to children that it's called vinegar. Then Hoseli has sent us a plate, a funnel, an empty balloon, empty bottle, and these supplies we can now use to solve the problem of how to inflate balloons without blowing into them. Maybe you have these same supplies there with you, so please join me and let's do the experiment together. Then let's practice to do a bit more observations. Let's measure 2 spoonfuls of baking soda on the plate. Then we can ask children to measure a certain amount, maybe 50 milliliters of vinegar on the baking soda. And let's do careful observations, what we can see and what we can hear. So we have here bubbles, we see bubbles, and we hear a fizzy sound. For children, it's quite difficult and demanding now to make an interpretation that there is gas formation going on. So to strengthen children's idea that there is in fact forming gas when we mix baking soda and vinegar, we can use a resealable plastic bag. And now you can take your plastic bag and measure 2 teaspoons of baking soda inside the bag. And then we make this kind of little twist here so that we can measure the vinegar so that it doesn't yet touch the baking soda. And let's measure about 10 milliliters of vinegar here in the bag. And then we carefully close the bag and we let the reaction happen again. Now the observations that children can make is that they see bubbles, they hear the fizzy sound, but they really feel that the gas is forming inside the bag. At this point, children always say that there is air coming inside the bag. If we are very accurate, it's not air, but it's carbon dioxide gas. But for children, it's great interpretation that there is some kind of gas forming inside the bag. And now, at this point, we can let children start their problem-solving process. So they have made observations, and now they can use them. How they could inflate the balloon by utilizing this similar kind of phenomenon that is happening inside the bag. And every single time children first suggest that they put inside the balloon first the baking soda, then vinegar, and then they tie the balloon and let the reaction happen. And great! That's a fantastic way of solving the problem. But usually children are not very satisfied because there is liquid inside the bag. So they don't want that there is liquid inside the balloon. Then we can use the storyline and help children to figure out that could we use the bottle Hoseli sent us somehow so that the liquid would be here inside the bottle, not inside the balloon. And quite often when children figure this out together, they come up with the idea that, hey, yes, let's put vinegar inside the bottle, and then we quickly put baking soda there also, and then we attach the balloon here on the top of the bottle. Fantastic! Let's allow children to test this idea. They might be very happy with this kind of solution, and that's enough for us. They have made the solution. But one thing is that children usually probably it takes a bit time from them to attach the balloon. So quite much of the gas gets out of the bottle before they attach the balloon. So the balloon remains quite small. And then we can once again return the storyline and push children's thinking a bit forward, asking that could we somehow prevent vinegar and baking soda touching each other before we have attached the balloon. And I have done this activity with over 1,000 children, and every single time someone has came up with the idea that, hey, let's put baking soda inside the balloon and vinegar inside the bottle. And then we attach the balloon and we don't lose any of the precious gas. So let's try this out. Let's measure two teaspoons of baking soda inside the balloon. You can do the experiment with me if you have your supplies there at hand. And then you can measure about 100 milliliters of vinegar in the bottle. And then we attach the balloon. And let's lift it up. And of course the end result is exactly the same as it was in the previous example. But if you compare now what children have learned if the activity is put in the form of playful inquiry. Children have learned science process skills. They have learned observation. They have learned measuring. They have learned making interpretations. They have also learned of how to make predictions. Children have learned probably interaction skills, social skills, when they together try to solve the problem. And the most important thing is that children has been able to test their ideas. So we don't want to prevent children to testing different kind of ideas how to solve the problem. And every single time we praise children's ideas, we praise that they have been suggesting and testing, and then we can help children to learn critical thinking skills by evaluating, is this the best possible way to do this, or could we come up with the new ideas? And when children finally are able to solve the problem, we gather together so that we can, for example, write a letter back to Robert the Hosely, or we can call Robert the Hosely and tell how we ended up in this solution and how Hosely can now use this solution to make his party happen. So, to wrap up, we have been discussing today why play is so important in young children's learning and how to engage children in learning science. So, it's very important that we allow young children to learn by play so that they can explore and use their creativity. We should leave room for children's ideas and their topics of interest. We remember that children are masters of wondering, so let's use this source of questions and wonders to create learning that really motivates children. When we use open-ended activities, we allow children in different developmental level and with different skills to feel that they are good and they are capable. By using integrative approach, we can at the same time teach, for example, science process skills and problem solving skills, critical thinking skills, and, for example, social and emotional skills. And we should remember that every child is a complete person. Children are not incomplete adults, but they are complete whole persons. They have already many skills, they have interests, they have experiences. So let's allow children to draw on these experiences and topics of interests, and let them act as active agents of their learning process. And play-based inquiry, it allows every children to learn at their own pace and have possibility to recognize their strengths. I thank you very much for staying with me today, having your time and learning about how to do play-based science education. So you can try out how does it feel like to do playful inquiry activities with young children. At Kide Science we have over 100 different kind of learning activities and lessons where children can learn by stories and play. Thank you so much and have a good day.